Hello everybody and welcome back to question number 23 now on the 2017 Fermat paper. So let's take a look at what question 23 has to say. Sylvia chose positive integers a, b, and c. Peter determined the value of a plus b over c and got an answer of 101. Paul determined the value of a over c plus b and got an answer of 68. Mary determined the value of a plus b over c and got an answer of k. The value of k is... Okay. So we've got three unknowns but only two equations, and then we've got to figure out this other equation involving k. I question whether or not we'll actually be able to get a, b, and c by themselves, but let's copy down the information we've been given nonetheless. A plus b over c is 101, and a over c plus b was 68, I think was the other one, and we want a plus b over c. Okay, oh, and so we probably actually can get a, b, and c, because positive integers will likely narrow some things down for us. So we need positive integers here. Okay. K is equal to this. A over c plus b over c is this expression. And hey, I've got an a over c and a b over c. So if I add these two equations, I will get a plus b plus a plus b all over c. And that's going to be equal to 169. Okay. So now what to do? Let's multiply by c. I don't know if this is going to help, but c plus 1 and then a plus b. Okay. Actually, I think this will do just nicely. So, yeah, I multiply it, so c times this, and then 1 times this, and yeah, they get added. So, yeah, c plus 1, alright. Now, imagine c. So c plus 1. So c plus 1 divides 169c. But c plus 1 and c have no factors in common, have a GCD of 1. Any two consecutive numbers have no factors in common other than 1. Okay, this is a nice little result. Because if, for example, d divided c plus 1 and d divided c, well, then it's going to divide their difference, which is 1. So d has to be a divisor of 1. Well, that can never happen unless d is 1. So because they share no factors at all, I can say that c plus 1 divides 169. 169 is 13 squared. So c plus 1 is 1, or 13, or 169. Those are the only options I can work with here. Okay. Now, if c plus 1 is 1, that would mean c is equal to 0. That's not going to happen. Because they said positive integers. Right? Positive integers. The positive part is what rules out the 0. The integer part is what led me to all this division. If they could just be random real numbers, there's no way we'd get an actual definite answer. I don't think. Okay, so it's probably 12, just because of how low these numbers are, but, maybe, just maybe. What could we do to figure it out? Well, if c plus 1 is 13, then we get a plus b, and then we get 169 times 12. So if c is 12. So we cancel out a 13 there. A plus b would be 12 times 13, which is 156, I think. 156. Okay, I see no immediate problem with that. Okay, now if C was 168, if C was 168, then we'd have 169 times A plus B is equal to 169 times 168. Those would cancel, and A plus B would be 168. And I don't see any problem with that either. K is A plus B over C. So in this case, K would be 13, and in this case, K would be 1. Are either of those possibilities? Well, only the 13 is possible. So I suppose we could just say, yep, the answer is going to be A. Although I'd like to, for a moment, try and figure out why K equals 1 isn't possible. I imagine because we're not going to get solutions for A and B that are positive integers. But let's find out exactly what's going on here. So our answer is A, and if that's all you want, that's okay. You can head on to the next question, but if C is equal to 168, A plus B is 168. So multiplying through by 168, I get CA plus B is, 168 times 101, an obnoxiously big number. And I can do the exact same thing with the 68, but I don't think I'm going to get anywhere useful. I should be able to... Actually, no, I should have left it like that. So 168A plus B, which is 168 minus A, is equal to 168 times 101. So that's 168A plus 1, all minus A is 168 times 101. But that tells me 168 has to divide A. Because if I just rearrange 168, A plus 1 minus 101 is equal to A. So 168 is a factor of A. And likewise, 168 times B plus 1 minus 68 will be equal to B. So 168 will have to divide B. But they both have to add up to 168 as well. So to be positive integers, that would mean that they're both at least 168. So, we've got a problem because they can't both add up to 168. Okay, so that's why K can't be 1. Now, I never actually worked out the values. If C is 12, then we get 12A plus B is 1212. And I know that B is 13 minus A. So 12A plus 13 minus A. 1212. Subtract off the A, we'll get 11A plus 13 is 1212. Minus 13, 1,199 divided by 11. I get A is 109. That doesn't seem right, but okay. And then same sort of thing with B. But we're going to get 12 times 68. This is 816. 816 subtracted 13. Divide by 11. B is going to be 73. And, well, those are positive integers, and they don't add up to 13 like I want. So what's going on here? Something's wrong. Something is definitely wrong. Did I do the whole question wrong? Oh no, a plus b is 156. It was when I divided it, I got 13. But then, oh, wait, no, that's why they can't be k equals 1. No, that'd still be fine. Yeah, so it's not 13 in here, it's 156. So that changes things a little bit. So 1212 minus 156 divided by 11. A is 96. That's looking a little nicer. And 816 minus 156 divided by 11 is 60. And yeah, hey, C divides both of those. So A over C plus B is going to be 8 plus 60, and that's 68. And A plus B over C is going to be 8 plus 5, or no, 96 plus 5. And that is indeed 101. And A plus B over C is 156 over 12, which is 13. Alright, so not only did I rule out k being equal to 1, because you'd need 168 to divide both a and b, but we also showed exactly what the values are. The question didn't ask for the little a, the little b, and the little c, but if it were a written question, say we're practicing for a Galois or Hypatia where they do ask for those things, we got it all worked out. Okay, so that was question number 23. And we got 2 more to go, so I will see you guys in the next video for question number 24. Ta-ta!